Hello, my differential equation student. Today we talk about section 3.2 about classification of point. We have some, just a moment. We have differential equation. Some function depend x multiplied by second derivative y plus function depend x multiplied first derivative y and function depend x multiplied by function y equals 0. We can easily divide by ax and we can easily rewrite our equation this form. Second derivative plus some function p to the depend x y prime plus q to the x y equals 0. And then we have definition. Point x equal a, we call ordinary point, for our equation if both of our function px and qx, both of this function is analytic at x equal a. Otherwise, x equal a, this means if not, x equal a, call singular point. Singular point. Okay, see some examples. Let's go example number 1. We have equation x y second plus y plus y prime plus x y equals 0. This means right standard form we need divide by x, and here we have y second derivative plus 1 over x y prime plus y equals 0. Here we have px is function 1 over x and qx is function 1. Function px is not analytic. Not analytic as at x equals 0. This means x equals 0. Singular point our equation. See second example. Okay, example 2. Here we have x second derivative plus sine x. I write parentheses when you can see first derivative is not inside sine. It's only first derivative multiplied by sine. X squared y equals 0. Standard writing will be plus sine x over x y prime plus x to the y equals 0, and our function is px will be sine x over x, and qx, q depend x, it will be only x. Q is analytically. What about px? Here we remember power series from sine x, and we can rewrite px will be 1 over x, and for sine x I use power series. This will be x minus x cubed over 3 factorial. It's Maclaurin series, all you remember. x fifths over 5 factorial minus x 7 over 7 factorial, and we can continue how long you want. But if you multiply it by 1 over x, you have 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial minus x to the 6 over 7 factorial, and continue power function. But this, we have series, we have polynomial. This means this function is analytic at x equals 0. And is mean x equal 0 is ordinary point for our equation. Now we have some theorem here. Theorem 1, who tell us let's x equal a ordinary point equation. Equation ax y second plus b depend x y first plus c to the xy equals 0. Then equation has two linear independent solutions. Then our equation has two linear independent. All you remember what is linear independent, right? Solution. Each of the form y depend x is power series for some coefficient x minus a power n and changing from 0 to infinity. Okay, see some example and looking how we can solve, how we can use this theorem and how we can solve it. Example. Let's go, we have x squared minus 4 second derivative plus 3x prime plus y equals 0. And here we have initial point y from 0 is equal 4, but value your derivative for point 0 is equal 1. Okay. Write a standard form. We can check in. We have second derivative plus 3x over x squared minus 4 y prime plus 1 over x squared minus 4y equals 0. How you can easily see x equal 2, x equal negative 2. This is our two singular points. Okay, taking some ordinary point and can write solution. We can easily see it's x equal 0. It will be ordinary point. What I'm checking x equals 0 because this is my polynomial. Looks easier and easier found all coefficient. Okay, ordinary point. And this means I can write my solution like y equal some power function, Cn x to the power n from 0 to infinity. This means first derivative, it will be power sigma n changing from 1 to infinity, Cn. Okay, I don't need parentheses here. X to the n minus 1. And my second derivative, it will be sum n. Start with 2, infinity Cn n minus 1. But power x is n minus 2. Use all this fact and plugging my equation and distribute. I have series. Here I need second derivative multiplied by x squared, and this is give me series, whereas n starts with 2, and here I have Cn n minus 1, but x power n minus second derivative multiplied by 4. It gives me 4 series, n starts with 2, Cn n minus 1, but power is x n minus 2. Then I have 3x times first derivative. You give me plus 3 power Cn n x n. N start with 1 to infinity. And then I have plus my function y. This means plus Cn x to the n and start with 0 to infinity equals 0. Okay. For I try rewrite my series when is n, all n start with 0. Can I do it this way? I think I can. What does mean? First series is move 2. If n is 0, this means first term is 0, because n 0 and you multiply it by 0. If n is 1, my second term will be 0, 2, because 1 minus 1, it gives me 0. This means for first series, I'm only write n start with 0 to infinity, Cn n minus 1, x power n. You see nothing changing because first two term here is 0. Second term, here I don't like power second series. I need power x to the power n. How I change? I write minus 4 series n start with 0 to infinity. Looking here, x before would start, if n start with 2, lower power was as x power 0. Now my n start with 0. Lower power need be safe x to 0. This means here is n. This means n minus 2, I'm substitute with n. This means index Cn is was twice more and twice add 2 more than you have power before. This means we have n plus 2. This is relation we shave. Now we have n, but power was 2 less. This means power n. This means here we have n plus 2. N minus 1 was 1 greater than power. This means now it's n plus 1. You see? Use this fact, we rewrite our series. Okay. Our third series is exactly, not exactly, we need n start with 0. This means, okay. But if n is 0, you have term who is exactly 0. This means only I am rewrite Cn n x to the n is nothing changing. And my last series is exactly how I need, and start with 0, Cn x to the power n equals 0. Now I can write all my, oops, sorry, I need move to. I need to write all my series together and take out x to the power n, and I have series and start with 0 to infinity, x to the power n, and what I have inside parentheses, n times n minus 1 Cn minus 4 C index n minus 2 n plus 2 n plus 1 plus 3n Cn and plus Cn. And this is series need be equal 0. This means each term will be equal 0. What kind of equation we have? We have, if you start distribute, simplify, if you have Cn, whose coefficient is n squared minus n plus 3n plus 1, and minus 4 Cn minus 2, n plus 2, n plus 1 equals 0. This means my Cn equal what I write Cn minus 2. It's 4 Cn. Okay, guys, see, just a moment. Cn plus 2. I'm moving plus 2. And it will be, you see my mistake? Right. Cn plus 2. This means Cn plus 2, if you're solving this equation, this will be Cn, if you're counting coefficient here, it will be n squared plus 2n plus 1, who is n plus 1 squared, divided by 4 times n plus 2, n plus 1, n plus 2. Okay. Cancel it. And I have this formula is Cn n plus, n plus 1 divided by 4 times n plus 2. What does mean? If I have some coefficient, I can find coefficient who stay 2 terms after. This means if I have C0, I can find C2. If I have C2, I can find C4 and continue. Remember our initial point. We have value our function for point C0 equal 4. Value our function for derivative, it will be 1. This means C1 equal 1. This means here we have C0 equal 4 and C1 equal 1. Use this fact, we can evaluate and has your function, it will be 4 plus x plus 1/2 x squared plus 1/8 x to the third plus 3/34 x to the fourth plus and continue. Okay. Doing some example from your something similar in your homework. Okay, this is number 8 from your book. What we have here? I have 2 2 minus x squared, y second derivative, minus x to the y to the prime, minus x y, sorry guys, plus, I wrote this, xy prime plus 16y. Y equals 0. And here we need found our solution. We try found looks like power solution, and we see our x equals 0 is ordinary point. This means we try found Cn x to the power n, whereas n from 0 to infinity. We now first derivative will be n Cn x to the n minus 1, and from 1 to infinity, and second derivative oops, okay, I write lower when we can see. I'm trying to save place, but it's not work. Okay, second derivative is will be series, whereas n start with 2, infinity, n minus 1, Cn x power n minus 2. Okay, use this fact, use all these 3 series, plugging in our equation and distribute. We have twice n start with 2 to infinity, because twice second derivative will be n minus 1, Cn x n minus 2, minus x squared multiplied by second derivative. X squared we put inside, and it's fixed our power. This means we have n start with 2 to infinity, n minus 1, Cn, but x power n now. Then we multiplied x for first derivative. It gives me minus series n start with 1 to infinity, n Cn x to the power n, and plus 16 times your function. This means 6 c to the n x to the power n, and start with 0 to infinity. Use trick what we did before. We rewrite our equation like first term is no big deal. You start with 0 or 2. If you start with 0, this means first your term is 0 and it's nothing changing. 2 I put inside, n plus 2, n plus 1, c n plus 2 index now, x to the n. Okay, minus Cn x to the n, here is 0 to infinity, minus series n 0 to infinity, Cn x to the n, and plus series 16 Cn x to the power n, and from 0 to infinity, equals 0. This means we have this kind of equation. If we collect all together, we have x to the power n, and start with 0 to infinity, and parentheses, twice n plus 2 n plus 1, c n plus 2 index, minus n minus 1, Cn minus n Cn and plus 16 Cn. All need be equal 0. This means each coefficient need be equal 0. Okay? If we write all together, we have twice n plus 2 n plus 1 Cn plus 2. Here we try collect how many n's, Cn's we have. We have n squared minus n plus n minus 16. Because I take it out, minus Cn. Okay? And we can see, oh no. Okay, we can see what we have. This means twice n plus 2 n plus 1 Cn plus 2. It will be Cn, here is n squared minus 16, will give me Cn. Here we can write separate, but I'm not sure it will be work better if you, because it's give us n minus 4, n plus 4, but it's, we not simplify anything, n plus 2, n plus 1. Okay, and see what we have. This means if we have here we have just a moment, we have initial point or not. I think it's not, we not have any additional point. This means I can write, this is problem. If n equal 4, this means your numerical will be 0, and this means b, c this is 6, it will be 0. But it's remember. Okay, we have c0, and then we can count in c to the second. C to the seconds this will be c0, n is 0, this means here we have negative 16 divided by 2. I forgot about this too. N equals 0, this means I have 0 plus 2 is 2, and this means I have times 2. This means I have minus 4 C0. C, next one, I can count in C to the fourth. What has happened? It will be C to the second. Now 4 minus 16 divided by twice 2 plus, I write first time, and then you can do it yourself, and 2 plus 1. And what we have here, you have minus 12 c to the second divided by 4 times 3, it will be 12, and 2, 24. This means negative c to the second half. But what is c to the second? This negative 4 to the c to 0. This means minus minus give us plus. This means twice c to the 0. Okay. What we have? C to the 6. We have, it will be c to the 4th. 4 squared, 16 minus 16. Remember, it will be 0, will not count in denominator. Okay, c to the 8. And what we have for c to the 8? It will be something depend for c to the 6. This means continually will be 8. What we have here? We have only c0, c second, and c fourth is non-zero. What happened if you have c to the first? This means we have some c to the first. What will be c to the third? C to the third, it will be c to the first, 1 minus 16, twice, 1 plus 2, 1 plus 1. This means we have negative 15 c to the first divided by 1 plus 2, 3. 3 times 4, 12. Or it will be minus 5 c1 to the fourth. Okay. C fifth, it will be c to the third, 9 minus 16, twice, 3 plus 2, and 3 plus 1. It will be minus 7 c to the third, and 3 plus 2, it will be 5. 5 times 4, okay, 2, 5, 4. And I continue. Then I'm plugging c to the first, and I have minus 30, plus 35 c to the first, and this is here will be 2 times 5 times 4 and times 4. And continue this work, you can find your series. Okay, and remember, after for even, after c to the 6, you have all of them will be equal 0. And c tens, because it's equal 0 and all even. This means even terms you have only few, and odd terms you have infinite. Okay, good. We're done for this section.